Okay, this is going to be, this is Sunday, right, the week before Christmas, basically. This is the sun coming up. This is sunrise. Been pretty heavy fog, and just a beautiful little scene outside the window of the sunset and how the sun comes up. What we're going to be talking about is how spin theory, with its points of precession, are going to be validated through the observation of solar events. And it's very important that we come to the conclusion that the events of the solar system that are made up of particles, such as atoms and spin, are going to be heavily influenced by those atoms and how they move. And that the solar movement, the movement of the whole, should be a reflection of its parts. And that's why we're watching the sunrise right now, and why we're talking about this, is that the sum of the parts should be viewed in the action of the whole. And that is the spin of the earth. The spin of the earth should represent how energy and mass is transferred from the sun to the earth, and how it will spin the particles, because it's how this energy and mass is being transferred. It's being transferred from atom to atom, you could say. This is on an atomical, a particle basis. The earth itself is not receiving the energy transfer, the mass transfer from the sun. The particles of the earth are receiving this, and in part they will react to the subatomic particle transfer of mass, and they will spin and they will precess at 90 degrees from the application of force. And when we say the application of force, we're talking about however this force is applied. It may be directly applied from the sun, and it may be applied at an angle depending on the magnetic field and the events of the mass, and how mass is affected by the sun in things of this nature. So what we're going to do, and we're seeing just a beautiful reflection here in the sun. I hope that's hurting my eyes already. So what we're going to do is look at the solar system and pretty much expect it to be a reflection of its parts. When you apply force to a spinning particle or an atom, it's going to want to move at a 90-degree angle to that application of force. It may move to the right if it's in right-hand spin. It may move to the left if it's in left-hand spin. But it is going to move. And it's going to do this 90-degree precession from the application of force. And when we keep stating that, because when we're looking at the events between magnetism and what we call gravity, the event gravity, or this event at a very close range, we're going to be at a distance too. We're going to be looking that force, that this mass is transferred, can be transferred at an angle. It's the line from the sun to here may not be the same. And as you get closer to an object that's emitting mass, you may be hit in a different angle than straight on, you could say. You could be hit at an angle that represents, as we know from magnetic field, at a 90-degree angle from the emission of source. So therefore, our precession would be towards or away from the emission of force. And we're going to look at this and make sure that we understand what we're saying. We don't want to trip over our own language. Okay. So what we're going to look in the sun is pretty well coming up here. And I guess what we'll do is kind of put me into the picture now. See if that helps. I don't know if it does. But what we're going to be talking about is, we look into the solar system, we're going to be looking for, see if this helps at all. What we're going to be looking for is that the Earth spins in a predicted manner, and that the moon spins with application of force to its parts in a predicted manner. And we're going to look at how the sun spins as an application of force in a predicted manner, and what is spinning the sun, and where its energy for this rotational event, this precessive event, will be. And this is pretty important. This is going to test our faith in spin and precession, in that although I believe we're going to come up against a few inconsistencies, I think we're going to be able to explain those inconsistencies, and I believe that as the sun comes up here, we're going to initially have some great successes at looking at the solar system and how it spins. As the Earth spins and rotates around the sun, is very consistent with precession and spin theory. And the moon is very consistent with precession and spin theory. But when we get into these inconsistencies, and I'm sure there will be some, we're going to try and look a little deeper, and we're going to have a little faith, of course. All things are a belief structure of some nature. And we're going to try and see if we can work through there. If we can't, of course, we're going to come up against a brick wall. Because in the end, we're trying to develop a belief, not a belief structure, but a consistency structure. A model that will be consistent, of course, and will get us closer to that point. And remember what we're talking about here, if you're coming on board a little later, is that we believe that items are in spin, and that if you apply force to them, they're going to precess. And if you do a frequency of application of force, the item that you're applying force to is going to precess 90 degrees at every frequency. And if you watch this, you're going to notice that the item in precession will have a tendency to describe an orbit or a circle around the application of force. And that is how we could define precession and frequency of application of force as the form of a circle in our universe. How you form circles, how you move things in circles. Okay, well, so much sunrise coming up, it's real pretty. Let's go ahead and close, and I'll take my time and I'll see what we got, okay?